Today's my topic is CW radar. So in the previous session I have told that what is a radar, what is the principle of radar, and what is the main functioning of a radar, and what is the working of a simple radar, what are the main components of a radar, and we have seen the pulsar radar block diagram and explanation of each block under the pulsar radars, and we have seen the types of duplexer. Under the duplexer we are calling as a branch type duplexer, and under that we are having two tubes, that is TR and ATR tubes, to work with the duplexer. And what are the main functions of duplexer? Okay, so like this we are having number of types, and under that to display some information of the target we are having number of scopes or number of displays. Under that we are having A to R tubes or scopes, and when we are having this concepts, under that the next type is CW radar. Okay, in this sessions I have saying something about the radar, that is classification of radar, and what is the Doppler effect, and what is the principle of CW radar, and what are the advantages and disadvantages of radar, and what is the working of FW CW radar, and what are the advantages and disadvantages of FW CW radar. Okay, so mainly the classification of radar, it is basically working of the radar, it is basically division into two parts, that is primary radar and secondary radar. Under the primary radars we are classified into two parts, that is CW radar and pulsar radars. Okay, in the previous video I have said about the pulse radar, and today we will discuss about the CW radars. And under the CW radars we are having modulated CW radar and unmodulated CW radars. Under the pulsar radars we are having MTI, that is moving target indicator radar, and the next one is Doppler radars under the pulse. So the radars are going to be classified into two types, that is primary and secondary. Under the primary it is classified into CW radar and pulsar radar. So under the CW radar it is classified into modulated and unmodulated, and under the pulse radars it is differentiated into MTI, that is moving target indicator, and the next one is Doppler radar. So this is the classification of a radar. So the next topic is Doppler effect. So what is the Doppler effect means? The source of oscillation or the observer of the oscillation is in a motion, an apparent shift in frequency will result. That means whenever the passing of signals from the source towards the target or towards the atmosphere, that frequency of signals, and when we are observing from signals from the target, that is calling as echo signals, it is also having some frequency. When the target is in the moving condition, the frequency of the observer is going to be changes. So that different signals, that is calling as apparent shift in frequency, that is difference frequency in frequencies is going to be calling as an Doppler frequency, and this process is going to be calling as Doppler effect. So based on this Doppler effect only we are having the CW radars. Why? Because continuous wave radar is mainly used for our moving target observation or moving target information. Why? Because in the pulsar radars it cannot detect the moving target, it only detect the stationary targets, that is stable target. And in the pulsar radars we don't determine the velocity of the target also. So that is the main drawback, and that can be overcome with our CW radars. And basic principle of radars, we can see this block diagram, that is simple CW radar. So when we are having some CW transmitter which will generating a frequency of signals, and it is going to be passing towards the antenna, that antenna will accept that certain frequency of signals, and whenever the target, we can observe this from the target we are going to be getting some frequency. Okay, it is a moving target. So when it is going to be moving target, the frequency is going to be changes. Why? Because if the target is moving towards the antenna, which will be sum of the frequencies, when it is going to be away from the antenna, it can be differentiated with signals. That means f0 minus fd. If it is moving towards the antenna, f0 plus fd. That means the transmitted signals at the same time echo signals. Okay, both the frequencies are going to be sum and differentiated with the moving of target away from the antenna and moving towards the antenna. Based on this only, we are going to be calculating the frequencies. So by having the frequency only, we can determine this frequencies. Okay, so from the antenna, if it is having some receiving of signals, that is f0 plus or minus fd, that is going to be given for the detector. It will acting as a mixture. Okay, this will having the mixing of transmitted signals. At the same time, from the observer, it is going to be having some signal frequency that is also going to be added with the signals. So whenever it is differentiated fd, that is given for the amplifier, which will be amplifies the signals to our IF frequency ranges. So that IF frequency ranges are going to be given for the indicator to have an information of the target, whether it is moving away from the antenna or whether coming towards the antenna is going to be given the information on the indicator. Okay, this is a simple operation of CW radar. So which is going to be using the Doppler effect to detect our frequency changes caused by the moving target, and it will be displace the relative velocity of the target, and the transmitted energy being continuously duplexed is replaced by a circulator. So that means in order to control the transmitted signals at the same time receiving signals, in order to control that, we are going to be using an circulator. Okay, what is a circulator means? Which will be providing the isolation between the transmitter and receiver. Just it will provide the isolation between the transmitter and receiver. So the transmitted frequency is received as a target moving from the radar. These incoming echo signals are FD, are heterodyne with the locally generated transmitted signals inside a mixer. Okay, the output of the detector is applied to the Doppler amplifier. What is the purpose of Doppler amplifier means? It is to eliminate the echoes from the stationary targets and to amplify the Doppler echo signals, that is FD. And it can be operate an indicating device such as frequency meter. That means at the indicator side, we are having number of meters. Not only with the display unit, we are having number of receiving sections at the receiver part. Okay, so this is the operation of simple CW radar. Doppler frequency for the CW radar is going to be calculated as FR equals to F0 plus FD. When the target is coming towards the antenna, that can be given as FR equals to F0 plus FD. That is F0 is nothing but an transmitted signals and FD is nothing but an different signals. And whenever the target is moving away from that, from the antenna, which can be calculated as FR equals to F0 minus FD. So whenever calculating the equation for the Doppler frequency, the R is going to be the distance from radar to target, and it is having the unit wavelength as lambda distance. So the total number of wavelength can be given as 2r by lambda when it is two-way path. One wavelength correspond to 2 pi radian phase. Already we have known that the wavelength can be given as 2 pi radians, and the total phase is going to be given as 4 pi r by lambda. That is the total phase of the Doppler frequency. This is the calculation of Doppler frequency for CW radar. So what are the application of this CW radar? To find out the target having some angle, elevation angle, velocity. It can be done within this CW radar. And to indicate that the presence of moving, whether it is the moving target or stationary target, which can be given the information with the CW radar. and it is going to be used to find out the radial velocity of the moving target, and it is used to find whether an object is approaching or moving away from the antenna. Okay, this can be the application of normal CW radar. And what is the disadvantage means it does not give any information about the range. Why? Because whenever we are using the pulsar radars, it can be giving some range of the target from the transmitter. Okay, and the next modified CW radar can be given as this, that is the radar, the Doppler radar with IF amplification. So whenever it is having the main blocks is CW transmitter oscillator, transmitter mixer, IF oscillator, IF amplifier, receiver mixture, detector, audio amplifier. Please note this diagram. So CW transmitter which will producing the continuous wave with a frequency of ft. This signal is going to be radiated towards the target by using transmitting antenna, and the transmitted signal ft and the IF oscillator frequency are going to be mixed up in the transmitter mixer, which will be producing the sum frequency, that is ft plus fi. That means continuous wave ft, at the same time oscillator frequency fi. Okay, both are going to be having the summation of these two signals, and receiving echo signal, that is ft plus or minus ft, and the transmitted mixture output are going to be the received echo signals and the transmitted mixer output are going to be mixed up in the receiver mixer to produce fi plus fd. Okay, that means whenever the receiver mixture input is ft plus fi, and we can get as fi plus ft minus ft plus or minus fd. Okay, so the receiver mixture output is amplified by using the IF amplifier. The IF amplifier output is demodulated in the detector to produce the Doppler frequency, that is FD, which will be eliminating the echoes from the stationary targets, and to amplify the Doppler echo signal FD, the amplified Doppler frequency is going to be displayed as the velocity of the target in kilometer per hour. Okay, so that means the receiver mixer output is amplified by using the IF amplifier. The IF amplifier output is going to be demodulated in the detector to produce the Doppler frequency. That means which will be eliminating the echoes from the stationary targets and to amplify the Doppler echo signals. Okay, totally we can displaying the velocity of the target in kilometer per hour. So what are the advantages of CW radar means? It is having a simple circuit and low power consumption, and it is giving the accurate measurement of the relative velocity of the target, and the size of the equipment is very smaller than that of the pulsar radar. It is used at a low transmitting power. Okay, these are the advantages of modified CW radar. That means it is having a simple circuit, low power consumption, size of the equipment is smaller than that of the pulsar radar, and it is using at low power transmitting power, and it is having the accurate measurement of relative velocity of the target, Okay, these are the advantages of CW radar. And the next one is disadvantages of CW radars. It does not give information about the range. In the modified CW radar also, it does not give the information about the range of the target. And if there are large number of targets, it does not give the accurate result. That means whenever we are having the number of target in our atmosphere, it is not giving the accurate result in our CW radar. This is the advantages of CW radar. And what are the applications of CW radar means? It is mainly used to measure the speed of automobiles, and it can be measured the speed of the missiles also. And whenever we are having some crickets or tennis ball online, it is nothing but an live programs. In that also we can have a speed of the ball in that sports. Okay, it is mainly used with the CW radar, and it is mainly used to measure the speed of the aircraft, and it is mainly used in our police radars, and it is mainly used to determine whether the target is approaching or moving away from the antenna. So these are the applications of CW radar. That is, it is mainly used to measure the speed of the automobiles, it is mainly used to measure the speed of missiles, and it is mainly used in our sports, that is cricket and tennis balls, to have a speed of the ball, and it is mainly used to measure the speed of the aircraft, and is mainly used in our police radars, and it is mainly used to determine the target is approaching or moving away from the antenna. Okay, so these are the applications of CW radar. So that means normal, when we are having a simple diagram of the CW radar, in this we are having a simple operation, but the modified is going to be having some with an IF amplification to get a result of the target. So better to have a clear idea of the target, we are going to be using the modified version of the CW radar. That's why it is going to be calling as FWCW radar, that is frequency modulated CW radars. So this is the figure of the CW radar, and in the CW radar also, not a modified, in that also what are the application means, which will be used to have an indication of presence of moving target, and it is also mainly used for finding the velocity of the moving targets, and it is also mainly used to have an object to be approaching or moving away from the antenna. Okay, these are the main applications under the CW radars. And what is the main drawback under the CW radar is nothing but it does not give the information about the radar, and in the modified CW radar also, it is not having any number of targets is going to be done, it is not getting any accurate results. Same, it is both are same, but we are when we are going to be using the modified CW radars, it is mainly used to have a clear idea of the target which is placed in our atmosphere, and in order to have a speed of the target also, it is nothing but an using with the modified CW radars. Okay, let us have a quiz. Antenna that does not belongs to the horn antenna family among the following are. Under the horn antennas, we are having number of horn antennas. What is that antenna which is not belonging to the horn antenna family? So the first option is pyramidal horn antenna, and the second option is conical horn antenna. The third one is biconical horn antenna, and the fourth one is none of the mentioned. So what is an answer? Please note this question. So whenever the antenna is going to be having different types, under the horn antenna which is having number of types, so in that family which is not belong to this antenna is nothing but an D, none of the mentioned. Okay, so the next one is patch antennas are the antennas of small size and are made up of. Patch antennas are the antennas of small size and are made of. First one is strip line, the second one is micro strip line, and third one is coaxial cables, and the fourth one is rectangular waveguide. So what is an option? So please note this question. So patch antennas are the antennas of small size and are made up of micro strip lines. It is not made up of strip lines. It is not made up of coaxial cables. It is not made up of rectangular waveguides. Why? Because rectangular waveguides and the coaxial cables are under the transmission line types. So it is not an antenna. It is nothing but a links or a cable which is going to be used for transmission of signals from one place to another place, from one device to another device. It is going to be used. These two are nothing but it is not an antennas. Okay, so the patch antenna is going to be made up of micro strip lines is the answer. So the next quiz. Reflector antennas are widely used to modify radiation pattern of radiating elements. That means in our antennas installation or antennas structures, the reflectors are going to be used, and that reflector antennas are widely used to modify radiation pattern of radiating elements. Is it true or false? Please note this question. So the reflector antennas are widely used to modify the radiation patterns of radiating elements. Is it true or false? It is an true. Why? Because when we are having an Yagi-Uda antenna, in our that we are having some reflectors. Whenever we are not getting some signals to our TV, we are going to be setting out of the reflectors to have an signal reception part. So it is an true. That is, reflector antennas are widely used to modify radiation pattern of radiating elements. It is very true. The next question is, lens antennas are classified into two types, one being fast antenna, the other being whether it is slow antenna or delay antenna or dynamic antenna or none of the mentioned. So please note this question. Lens antennas are classified into two types. One is being as a fast antenna, the other is whether it is slow antenna, delay antenna, dynamic antenna or none of the mentioned. So what is an answer? It is an delay antenna, not with the slow antenna. Why? Because one is calling as a fast antenna means the other will be the slow. No, it is not correct. It is a delay antenna. That means lens antennas are going to be classified in two types. One is going to be a fast antenna, the other is going to be delay antenna. And next quiz. High directivity required in radar communication is satisfied using this type of antennas. So what type of antennas are used to satisfy the radar communication with a high directivity? Okay, so whether wideband antennas or whether is going to be antenna arrays or slot antennas or patch antennas. So please note this question. That is high directivity required in radar communication, that is going to be satisfied in the type of antenna means it is wideband antennas or antenna arrays, slot antennas or patch antennas. What is an answer? That is antenna arrays. That is the combination of antenna elements that are going to be grouped to have a high directivity. Okay, so in order to get the high directivity in our radar communications, which type of antenna is going to be used means it is an antenna arrays. So the next question, an antenna source that radiates energy uniformly in all the directions is called. An antenna source that radiates energy uniformly in all the directions is called isotropic source, an isotropic source, point source, none of the mentioned. So an antenna source that radiates energy uniformly in all the directions is called, whether it is isotropic, anisotropic, point source, none of the mentioned above. So what is an answer? Please note this question. So an antenna source that radiates energy uniformly in all the directions is going to be calling as whether isotropic source, an isotropic source, point source, none of the mentioned above. So what is an answer? That is isotropic source. Why? Because isotropic is nothing but the radiations are going to be in all directions, not in a single direction. That is not in a unidirectional. Okay, the antenna source will be radiating the energy in all of the directions, is going to be calling as isotropic source. Next, antennas that radiate energy only in a specified are called an isotropic antennas. Is it true or false? The antennas that radiate energy only in an specified area or specified direction are going to be calling as an isotropic antenna. Whether it is true or false, please note this question. An antennas that radiate energy only in a specified direction is going to be calling as an isotropic antennas. Whether it is true or false, what is an answer? That is true. When the antennas radiating the energy only in a specified direction are going to be calling as anisotropic antennas. So it is true, and the answer is true. Next quiz. Range is, what is mean by a range? Direction, distance, detection, duplexer. So what is a mean of range? Note this question. So what is the range? That is direction, distance, detection and duplexer. So what is an answer means? It is nothing but an distance. Next question. Radar is classified as primary and secondary, active and passive. How it is going to be classified? Whether the radar is classified as primary and secondary or active and passive. Please note this question. The radar is classified as whether primary and secondary or active and passive. The answer is primary and secondary. The radar is basically classified into two types, that is primary and secondary, and under the primary it is going to be classified into pulsar radar and CW radar. Under the secondary it is going to be used only for the artificial, that is whenever it is using the radar, it is mainly used for an application part. that is going to be calling as secondary. And under the primary, it is classified into two types, that is CW radar and pulsar radar. It is not going to be classified as active and passive. So in this session I have told about the radar, that is nothing but an CW radar. So we are having a small idea about the CW radar and what are the advantages, what are the disadvantages, and what is the modified CW radar. Okay, so in this session I have told about the classification of radar. So in the previous session I have told what is a radar, so what is the principle of a radar, what is the working of a radar, and what is in this session I have told about the classification of radars. Why? Because when we are having the classification of radars, it is division into two parts, that is primary and secondary, and under the primary it is division into two types, that is CW radar and pulsar radar. And the next one is Doppler effect. So what is the Doppler effect? Means it is having a difference of the frequency, that is if either the source of oscillation or observer of the oscillation is in a motion, that is it is going to be moving, and a difference frequency, that is an apparent shift in frequency will result, and that frequency is going to be calling as Doppler frequency, and the process involved in this is going to be calling as Doppler effect. So why we are considering with this Doppler effect means it is mainly used in our CW radar. Sometimes it is also calling as CW Doppler effect radar. Okay, this is that. And we are seeing with the principle of CW radar, basic principle involved in our CW radar, and it is not having any IF amplification, but the other, that is modified CW radar, is going to be used. Okay, so in this CW radars we are having isolation with the circulator. Okay, and Doppler frequency is nothing but 10. How we are going to be calculating means FR equals to F naught plus FD, that is when the target is going to be coming towards the antenna, and FR equals to F naught minus FD when the target is moving away from the antenna. So R is the distance from the radar to target, and the wavelength is lambda distance, and total number of wavelength is nothing but n equals to 2r by lambda. It is in a two-way path, and one wavelength is going to be corresponding to 2 pi radian phase, we have already known, and the total phase is given by 4 pi r by lambda. And what are the applications of CW radar means it can indicate the presence of moving targets only. We can find out the radial velocity of the moving targets, and we can only say that the object is approaching or moving away from the antenna. Okay, that can be seen with this applications. And mainly what is the disadvantage means it does not give any information about the range of the target. And this is the modified CW radar. In this we are having then IF amplification. Okay, so in the previous CW radar and in this radar, both are having some differences. What is that means? In this we are having some IF amplifications. Directly we are going to be using IF oscillators and IF amplifiers. In the previous class, in the previous CW radar, we don't have the IF oscillator and at the same time IF amplifier also. Okay, so this is the modified CW radar. So modified CW radar, in that the main intention is nothing but the receiver mixture output is going to be amplified by using the IF amplifier. So the IF amplifier output is going to be demodulated in the detector to produce the Doppler frequency, that is FD, which will eliminate the echoes from the stationary targets. And one more thing, under the CW radar, the moving target is going to be detected, but whenever we are having the stationary target, it is not going to be done. Why? Because it will eliminate the echoes from the stationary targets, and it is going to be used to amplify the Doppler echo frequencies, that is FD, and the amplified Doppler frequency is going to be displayed as a velocity of the target in our indicators. Okay, it can be shown in kilometer per hour. Okay, this is the CW radar explanation, and in this CW radar explanation, the main parts are CW transmitter and IF oscillator and IF amplifier. So basically this is the modified CW radar with IF amplification part. Okay, this is this, and in this, what are the advantages and what are the disadvantages of CW radar? In the modified CW radar also it is having some drawbacks, and in the general block diagram of the CW radar is also having some drawbacks. So what are the drawbacks? Means it does not give any information about the range, and whenever we are having the CW radars, if we are having number of moving targets, it does not give the accurate results. That is a main drawback under the CW radar. That is the main drawback. And what are the advantages? Means it having the simple circuit and low power consumption, and size of the equipment is very smaller than that of the pulsar radar, and is mainly used at low transmitting power, and which will be showing the accurate measurement of relative velocity of targets. These are the advantages. Okay, so advantages and disadvantages of the CW radar. So whenever we are having the CW radars, I don't have written the application of CW radars. It is mainly used for measuring of speed of the automobiles or any missiles, and is also used in our sports to have a speed, to measure the speed of the balls like cricket and tennis balls, and it is also mainly used to measure the speed of the aircraft, and it is mainly used in our police radars. It is mainly used to determine whether the target is approaching or moving away from the antenna. So like this, we are having number of applications under the CW radars. So this is about our modified CW radar and simple block diagram of CW radars, and we have done number of quiz based on the radars, at the same time based on the antennas. Okay, so you can observe that the drawbacks of the simple block diagram of CW radar and modified CW radars both are same, and at the same time advantages of CW radar and at the same time modified CW radar both are same. Okay, so whenever we are having the classification also, we are under the secondary part. I have not shown any type of the radar. Why? Because it is mainly used for our special application part. It is mainly introduced only in the special application it is going to be used. So under that we don't have any classification under the secondary type. Okay, so in this session, classification of radars, we have seen about what is a Doppler effect and what is the main principle of general CW radar, and what is the advantages and disadvantages of general CW radars, and what is the modified CW radar, that is FWCW radar. We are going to be calling as FWCW radar, and what are the advantages and disadvantages of radars, and we have already seen about the applications of CW radar. So in this session it is very clear. In the previous session also I have covered with all of the topics with the radar definitions, radars, types of the radars. Under the pulsar radar also it is going to be done. Okay, thank you.